I'm just going to give it another sec, see if anyone else is with us. How did you get on? Sorry, I forgot to post the average questions, 3, 4, 5, 6. Did you do them anyway? Any problems with them? Anyone done or not done?
Yeah, most of them were fine.
Thanks, Matthew. Anybody else? 3, 4, 5, and 6. Did you do them? Did you struggle with them? Any you want me to go over?
3 and 4 were grand. 5 was like okay, and then 6 was grand.
Good. Okay. Yeah, 5 is just, you're going back to your trig again, which is always slightly more complicated. And I think I only got one submission of the past papers. So we have 12 on there. I think I'll get started. So basically, we're at the end of the chapter. So what I'm going to do is pull up revision notes on integration and then go through the papers that I posted, and we'll do a test next Monday afternoon. So let me just pull up what I have on notes for integration. And I'll put these up on Classroom. Here we go. Hopefully they show up all right. Can you see those okay?
Yeah.
Yeah.
All right. So integration, as we know, is the opposite of differentiation. Okay. So remember this function that dy is f prime of x dx. So just if you go back to your differentiation just to see where it comes from, dy dx is f prime of x. So if you rearrange that, you get dy is f prime of x dx. And when you integrate both sides, you get y is equal to the integral of f prime of x dx, or f of x plus c. So the integral of f prime of x is f of x plus c. So remember, if you have the slope or the rate of change, that's f prime of x, okay? And if you integrate that, you're going to get the f of x, okay? And don't forget your constant of integration. And just in terms of what we call it, f prime of x is known as the integrand, okay? And then we have our rules, which are in the tables anyway. So it's just the opposite of differentiation. So the main rule is if you have a power of x, you add 1, divide by the new power, add c. Few other rules. If you have a constant, so say it's a times f of x, then you can take the constant outside the bracket. Sorry, there should be an integration sign there. Sometimes it gets a bit funny when it's changing from Word to online. I'll fix that anyway. So you can bring the constant outside and just focus on integrating the function itself. If you have two functions added or subtracted, you can just integrate them separately. And again, the integral sign has disappeared there. And there's just an example of that. So the 5 in front doesn't really matter. You just do x to the 4 over 4, and then you multiply it back by the 5. We're all used to all of this by now, and all those pluses and minuses can just be put in at the end. There's a few cases when you don't have x to the power of n, then you're going to need to use your rules of indices, which are in the tables on page, whatever it is, 29, 30, something like that. So if it's below the line, you bring it above the line and make it a minus. If it's a root, remember the number under the root is the power. So it's power over root. So it's, if you have any number here, the n, that goes below the line, okay? And sometimes we've done a lot of ones where you might have a combination of both of these rules. Any questions so far?
No, not really.
And then I go through, so there's all the different examples there, various combinations. If you have something like one thing divided by another, simplify it before, because we don't have an integration rule for multiplying or dividing. So you have to simplify it. If it's dividing, you need to divide the top by the bottom. And sometimes that might involve factorizing. Okay, so there you can divide x cubed by x and get x squared, and 5x over x is just 5, and then that's very easy to integrate. So the worst thing, the hardest thing in integration is just simplifying the thing so that you can apply the rule. Okay, here we want to simplify it by bringing that above the line, so you've got x to the minus 5, and then you just go ahead, add 1, divide by the new power. This one here, we're going to change it to a power, so it'll be 2 over 3. And be careful with your fractions. When you add 1, you're going to get 5 over 3, and dividing by 5 over 3 is the same as multiplying by 3 over 5. If you have something like this, which looks a little bit horrendous, change your roots to powers and then use your rules of multiplying out powers. And you might have things like that. One of the exam questions I had last night was e to the x times, and then there's some other e powers in here. Multiply it out. If you see multiplication inside an integration, you have to multiply it out and simplify it somehow, okay? And we'll come back to what you need to do for trigonometry in a minute. Is that okay with everyone?
Yeah, that's grand.
Okay, so you're just using the rules to change it, then you multiply those out using your rules for multiplying indices. And if you're dividing by a fraction, remember you turn it upside down and multiply. And then here you've just got something squared, so you have to multiply that out. Okay, so remember you don't have a rule in integration for multiplying or dividing, so you have to do the multiplying or dividing first, then you can integrate. For the constant of integration, we're used to working this out. You need some additional information, okay? They might give you a point on the curve. So it might be something like f of 3 equals 5, okay? So if you sub in 3 for x, then you know that y is 5, and that'll allow you to work out c, okay? Does that make sense? Okay.
Yeah.
You might be told that the slope of the tangent at a point, okay? So if you're told that, remember that's dy dx. Or you might be given the maximum or minimum point on the curve. Remember that means the slope is equal to 0. Okay, so that's just, information can sometimes be kind of disguised. You have to be able to say, what does this actually mean? So if you're told the slope of the tangent, you remember that that's dy dx. If you're told a point is a maximum, you know that's where dy dx equals 0. Everybody remember that? When you have a curve,
Yeah.
At the top or at the bottom, the slope is horizontal, so dy dx is 0. And that's just an example of that. We all know how to sub in for those. Okay, other standard integrals, and these are just, these first few are taken straight out of the tables. E to the x is just e to the x. If you have a number in front of the e, in front of the x, you divide by that number. So it's 1 over a. The input is a to the ax, that stays the same. So your input, which is also called your argument, stays the same. This one is just straight out of the table. So that might be 5 to the x or 9 to the x or 12 to the x, whatever. A will just be a number. Okay, so you just have 12 to the x over ln 12 or whatever it happens to be. The sign and cost in the tables, you only get the formula without the a. So you have to remember to stick the 1 over the a. And this one here is in the table. So that's your kind of, if you're not sure what to do, go back and look at the e to the ax and say, okay, it's 1 over a. And sign and cost the same. It's 1 over a and 1 over a. Okay, and the minus is there already. Okay. So e to the 4x is just, that's just standard. So 1 over 2 sine cos 2x. This one is using your a to the x. So that's a to the x over ln a. And then you'll have 3 over 6, which is 1/2, change cos to sine. This example here is one of the ones, they rarely come up, but it's going back to, because we don't have, see this, what they're saying is find this. which is a multiplication, and we don't have an integration rule for multiplication. So they have to give us a little bit of information to kind of work backwards. Okay, so you start by figuring out dy dx. And then you remember that the integral is the integral, dy is the integral of f of x dx, or the integral of y dx. So dy dx, you're just going to differentiate this. Okay, so that's 3 cos 3x. This one you'd have to use, this is a very complicated, I don't think they give you something like this. This one you'd have to use the product rule for. So it's u dv dx plus v du dx, you get that. And I've written it over here. Okay. And then what you do is once you have dy dx, you bring, using our very original rule, that's dy dx is equal to f prime of x. So dy is f prime of x dx. So now you have an expression. When you integrate dy, you get y plus c. When you integrate this, you can integrate this part, you can integrate this part, and this is the one we're looking for. Okay, so we know y because we started off with y up here. We can do this bit, we can do this bit, and then the bit that's left is just going to be y plus c minus the integral of this minus the integral of that. Does that make sense? So y, I'm putting back in what I started with for y is this. 3 cos 3x becomes sine 3x. This becomes 2e to the x, and then this I can't do. So then to figure that out, it's just the 2 on the left minus the 2 on the right, and then the constant of integration. Okay, and the sine 3x, you see that cancel, and then you're just left with this here. Okay.
Yep.
And they're all indefinite integrals. So that's just practicing how to integrate. When we get into the applications of integration, which is finding the area, finding the speed or the velocity of the acceleration, and finding the average, then we want to do definite integrals. Okay. So we won't have a constant of integration anymore. Okay. So acceleration, velocity, and displacement. We know that velocity is the rate of change of displacement and acceleration is the rate of change of velocity. So this is for integration, you've got the opposite, okay? And these you have to remember, they are not in the tables, all right? So distance is the integral of speed, speed is the integral of acceleration. So usually if you start with acceleration, you integrate to get the speed, and then you integrate the speed to get the distance, okay? And they'll give you information at time 0. Normally they'll give you what the speed is at a certain time or what the displacement is. Okay, so remember speed and velocity are pretty much the same, displacement and distance, okay? You don't need to worry about it. Velocity is a vector and so is displacement, but the size of them, which is all we're interested in, is the speed and the distance. So you integrate A to get the speed or the velocity, you integrate the velocity to get the distance or the displacement. And then you use whatever information they give you to find the constant of integration. So I'm going to just skip on through that to go to the past papers on that. And for definite integrals, if you have the limit a to b, you work out to do your integration, and then it's just sub in b. When you work it out, you put in f of b minus f of a. And the constant of integration disappears. This is the definite integral. Okay, so we know how to do all that. Areas under curves. Basically, integration is a sum. It's continuous, okay, rather than discrete. So it's not definite, distinct slices. It's continuous. So see here, this has been put into slices, discrete slices. Discrete just means that you can separate them. So we could use all those rectangles to get an average or an estimate of the area from here to here. But by using integration, we can get the actual area. Okay, so I'm not going to go through that. That's just the theory of how it works. But the area under the curve from A to B, start at A, finish at B, integrate f of x dx. You have to get the limits right. Okay, before you do any integration, make sure you know your limits. Okay, so find the area under the curve of that. And notice it's not saying what the limits are, it's just saying under the curve. it's a negative x squared. That means it's a parabola. So I'm just going to, so basically just switching over to the camera, if I do this quickly. So you know it's going to look like an upside down U, okay? There's your parabola. So we need to find the area under that, okay? We need to find where to start and where to end. So you need to solve f of x equal to 0, and that'll give you your a and b. So you're solving a quadratic to find your limits. Okay, so you can't do these until you know the limits. So the first thing you need to do is find the limits. Solve f of x equal to 0. Okay, and because it's a negative, we just change it so that it's positive. Okay, because that's easier to integrate. So the x squared is positive. Do your factorizing. I'm kind of skimming through this. You can go back through it. Okay, you get your two possible values for x. That's your limits of integration. So when you do your integration, they're going to be the top and the bottom. Okay, then you put back in your f of x, do your integration. You'll have two brackets. You sub in the 3 into each of these, and that's the first bracket, minus, don't forget the negative here, and then you sub in the minus a half, and that's your second bracket. So 3x is 3 times minus a half plus 5 over 2 times minus a half squared. And notice that the minus is inside these smaller brackets. When you're subbing in, use brackets. Everywhere there's an x, use brackets. And if there's a negative, make sure that it goes inside the brackets. Okay, so if either of your values is a negative, make sure that your negative is inside the brackets. And then once you have it written like that, get out the calculator, figure out this one. You get the calculator, figure out the second one, and then put them both together. Okay. Few special cases. If the curve crosses the x-axis, so if you've got a bit above and a bit below, the above would give you a plus value and the below would give you a minus value. And if you add them both together, they'll cancel out. So what you have to do is you have to do each separately, okay? And then add the absolute value of each area. So if you notice here, when you're doing your limits, there's going to be 3 places for crosses. So you have to say, call it A, B, and C. So you'd have to integrate from A to B, figure that out. Then you'd integrate from B to C, figure that out, and it should be negative. Forget about the negative, just add the 2 absolute values. Does that make sense?
Yeah.
Oh, still with me? Okay.
Yeah.
And then if it's between the curve and the y-axis, instead of doing integral of f of x dx, you do f of y dy. Okay, that's all you have to do. So a lot of the time, what you would need to do there, if it's written as y equal to x squared or f of x, you have to rearrange the function. So you have to do the opposite. Okay, so here, x would be equal to the square root of y. So what you're putting in, f of y is x. So you're putting in the square root of y in there. Okay, and what you're doing, these 2 points, well, you're actually told those. But remember, if you're figuring them out, they're 2 y values, not 2 x values, because they're on the y-axis. And between 2, sorry, I should have said between 0 and 4 there. Or actually, this should have been, sorry, that should have been a 2. So that answer is probably wrong. I'll come back and fix that before I post. And if you've the area between 2 curves, okay, so there's the area. So say you're trying to get the area between a curve and a line. This green, this is what you want to figure out, this green bit here. And you can see that's equal to the kind of beige part minus the red part. So it's the top graph, which is x, minus the bottom graph, which is the line, which is g. Okay, so that's what you're doing there. And again, the key thing is to get your limits of integration. First thing you want to do is find these 2 points where the line and the curve or the 2 curves cross. And then it's just the top minus the bottom. So which one is on top, and subtract the bottom one. Okay. And then the last thing is the average value. And you're just using this formula here, which again, this isn't in the table, so you have to remember that yourselves. Okay, so if you're asked to get the average, once you see average value in a question on paper 1, it's going to be integration. Okay, and you're going to use this formula here. So you'll have your two limits. It's 1 over b minus a, integrate from a to b. And it's actually, the integration itself is very easy to do. So I'm going to skip that example and just go to the papers that I posted. Is that okay?
Yeah.
Anybody,
Yeah.
any questions? Good. I should have recorded all that anyway. Do you want me to do a voiceover of those notes again? Would that be helpful?
Yeah, I think so.
Yes, please.
Yeah.
Yes, please.
Somebody try and before I start teaching, will you remind me to record things? Okay, so past papers. And I have put these up, so questions. So this was your exercise from the other day. I'm just going to put them on one side. So can you see that okay?
Yeah.
Yes.
So what I'm going to try and do is get through an area one, an acceleration one, and an average one. And then if you could do one each of those, okay? So you've got, this is the 2020 question, okay? And I'm going to record this before I forget, so then to be available for you to go back over. Okay, so the first thing we need to do, and they're actually telling us to do it, is find the coordinates of the intersection points of the curve and the line. So the line is y equal to x plus 4. The curve is 6x minus x squared, and where they intersect is going to be your limits of integration. That's where you're going to start and end your integration. And notice it says coordinates of the intersection point. So we can solve to find x. Don't forget to sub back in to find y. So where they intersect, these two are equal to each other. So that's your equation that you're going to solve. Set the line equal to the curve. Rearrange it so you've got a regular quadratic. So we want to take these over to the other side. So you'll have x squared minus 6x plus x is minus 5x plus 4 equal to 0. Okay, and then factorize that. You'll have minus 4 minus 1. Okay, so either x is equal to 4 or x is equal to 1. So this is clearly the 1 and this is the 4. And we need to find the y to go with each of those. So if x is 4, and you can use either of these functions because remember they're both the same at these points. So obviously the line is easier to work out. If x is 4, then y is equal to 8. I'm just writing that there to show I'm using this function. So if x is 4, y is 8, and if x is 1, 1 plus 4 is 5. So the coordinates are 4, 8, and 1, 5. Hence or otherwise, find the area of the shaded region. So I'm going to integrate from a to b of f of x minus g of x dx, where f is the top one and g is the bottom one. And I can see the top one here is the curve and the line is on. When I start here, go to here, the line is under the curve for that whole time. Okay, so it's starting at 1, finishing at 4. Okay, that's my A and my B. F of x is the curve, so that's the 6x minus x squared minus g of x. But anytime there's a minus, put it in brackets. All right, and then before I integrate, I can simplify that. I'll put the minus x squared in front. Start with it, and then you've got 6x minus x is 5x, and then minus 4. Now do your integration. So minus x cubed over 3 plus 5x squared over 2 minus 4x. And you're starting at 1, finishing at 4. So in your 4, you've got minus 4 cubed, which is minus 64. Now the minus, notice here, is not it's not negative 4, so it's minus x, open your brackets, put the 4 inside there. So the minus is outside the brackets. Plus 5 times 4 squared minus 4 times 4 minus negative brackets 1 cubed over 3 plus 5 times 1 squared over 2 minus 4 times 1. And obviously with the 1, it's all going to be just 1 anyway. And then when you take your calculator, you can put it in exactly as you've written it. So negative brackets 4 power of 3 over 3 plus 5 brackets 4 squared over 2 minus 4 by 4 is 8 over 3 minus, and then that one. And what you can do with the calculators is go back and you can just change all the 4s to 1. So instead of typing the whole thing in again, I'm just going to delete the 4, change it to 1, arrow back to here, delete, change it to 1, arrow back to here, delete, change it to 1, and you've got minus 11 over 6. And don't forget, that's inside a bracket, so it's minus negative 11 over 6, okay? And then I'm just going to do 8 over 3 minus my answer, which was the negative 11 over 6, and that gives me 9 over 2. And you can leave it like that, or if you want to, you can say that's 4.5. Okay, any questions on that one?
No, that's grand.
Yeah, fairly. Their integration, I think, is one of the nicest questions on the paper. As long as you kind of keep the head, get your limits, remember to simplify before you try and integrate. Okay, so the next question then, let me set it up before I start recording, is this was an acceleration one, okay? So again, start recording. Actually recording. Okay, so acceleration is given as a is equal to 4t minus 3, and you can put it in the units if you want, meters per second squared. Find the acceleration after 5 seconds, dead easy. That means a, and actually I should really write this as a as a function of t. So if we're subbing in whatever value of t, it gets put in there. So a when t is equal to 5 is a of 5, so that's just 4 times 5 minus 3 is 20 minus 3 is 17. 5 marks for Jan. Find the speed, v of t. So v of t is just the integral of a of t. And just remember the t just means it's a function of t. That's the integral of 4t minus 3. And that's 4t squared over 2, which is 2t squared minus 3t plus some constant. And that's your next part. Okay, and that's, if you look, it's in the form at squared plus bt plus c. So a is equal to 2, b is negative 3, and c is still c. So far, we don't have enough information to find out c. Part 3. Now they're giving us some information to let us find out c. They're saying speed is 11 after 2 seconds. So that means v equals 11, and that's when t is 2. So if you want to write it in this way, or you can say t equal to 2 means v is equal to 11. You could do it that way. So we're going to sub in 2 for t, and we know our answer should be 11. So 2 by 2 squared minus 3 by 2 plus c equals 11. That's 2 by 4. And again, you can use that's 2 fourths. It's 8 minus 6 plus c equals 11. That's 2 plus c is 11, so c is equal to 9. That's find the value of c. And then the last part is find the distance. And we know that the distance is the integral of the speed or the velocity. Speed and velocity are interchangeable. So I'm now going to integrate my velocity, which up here was 2t squared minus 3t plus, and we now know c is 9. Integrate that, you've got 2t cubed over 3 minus 3t squared over 2 plus 9t plus a new c. And to find that C, they tell us that if T is 0, S is 0. So S of 0 equal to 0 means 0 minus 0 plus 0 plus C equals 0. So that means that C is equal to 0. So S is just 2t cubed over 3 minus 3t squared over 2 plus 9t. And we want to find the distance in the first 3 seconds. So that's S, now t is equal to 3. So just 3 cubed over 3 minus 3 by 3 squared over 2 plus 9 by 3. Plug it into calculator. 2 brackets. 3 cubed over, oops, sorry, over 3 minus 3 brackets 3 squared over 2 plus 9 3s is 27 is 63 over 2 or 31.5, and that's meters. Okay, any questions on that one?
No.
No, that's good.
But see, so there, I think, as I say, it's a really nice question, integration generally, as long as you just remember you have to simplify. Okay, and then we do one on average. So the one on average, I think, is a little bit extra in it as well, just practicing the integration. So let me just start recording again. So the next one down, evaluate the following. That's very simple. Now, I'm going to do this one because I don't think we really spent much time on this. If you notice, it's a multiplication. Okay, it's sine 3x. Sorry, put back on the camera. Sine 3x cos 2x dx. And that's a problem because we do not have a formula for integrating something that's multiplied. So what you do, this is pulling in your trigonometry now. You go to page 14, 15, which is all the trigonometric identities. And you want to find one that has sine times cos. And that's on page 15. There's cos. Here's sine cos. Okay, so sine A cos B, I would bring the 2 over. It's going to be a half. So I write it down here. Sine A cos B is equal to a half sine A plus B plus sine A minus B. And if you remember from when we were doing these, you always want A to be bigger than B, which it is. If it wasn't, you just change the order. So A is 3x and B is 2x. So that's going to be, and I can just write the half outside. Sine A plus B is sine 3x plus 2x is 5x, plus sine A minus B is 3x minus 2x, which is x. And now that's nice and easy to integrate. Okay, so it's a half. Sine becomes minus cos, and then because there's a 5, we're going to divide by the 5. And then that's just 1 minus sine x. And you're going from 0 to pi over, oh, sorry, cos. 0 to pi over 2. So leave the half out. Your first bracket is going to be minus cos 5 pi over 2 divided by 5 minus cos pi over 5 pi over 2. And the second bracket is going to be minus cos 0 over 5 minus cos 0. Okay, now you can put it into the calculator and make sure you're on radians. So if you go into your setup, angle input is 2, the gradients is 2. And you can put that in, but if you're smart, you remember when cos is pi over 2, or 3 pi, or any pi over 2 of cos is going to be, the x coordinate there is going to be 0. So our first bracket here is going to be 0. You're going to have a half times 0 minus, cos of 0 is 1. So that's negative 1/5 minus 1. And minus 1/5 minus 1 is minus 6 over 5. And then the 2 minuses cancel. So that's a half times 6 over 5, which is 6 over 10 or 3 over 5. Okay. And then I'm just going to move on, find the integral. Okay, and this one again, very quickly, e to the x times e to the 2x minus e to the negative 3x. Because we're multiplying, go ahead and do the multiplication. So if we multiply, the same base means we add the powers. So x plus 2x is 3x, and minus 3x plus x is minus 2x. And then you just go ahead and integrate that, which is very straightforward. E to the 3x over 3 minus e to the minus 2x over negative 2 means I can just change the sign there to 2, and then plus c. And that's that question done. And the last part then is our average. So we want to find the average of 3x cubed minus 2x squared plus 4x plus 2 on the interval 1 to 4. So that's A, that's B. And remember, our formula for average is integrate from A to B, and you're going to divide it by A or B minus A. So that's 1 over 3, 4 minus 1. And if I integrate it, I've got 3x to the 4 over 4 minus 2x to the 3 over 3 plus 4x squared over 2 is 2x squared plus 2x from 1 to 4. And that's going to be 3 times 4 to the 4. So wherever there's an x, you're going to put in your bracket. 4 cubed over 3 plus 2 times 4 squared plus 2 times 4 minus 3 over 4 minus 2 over 3 plus 2 plus 2. So with the ones, I'm just not bothering to put in the brackets. Okay. And then again, get the calculator out. 3 brackets 4 and 4 over 4 minus 2. 4 cubed is 64. I'm just going to put in 64 over 3 plus 2 times 4 squared is 16 plus 2 fourths is 8. That's 568 over 3. And don't forget the 1/3 outside. And then minus the second bracket is 3 over 4 minus 2 over 3 plus 4 minus 49 over 12. So I have my 568 over 3 minus the thing I just worked out. The answer is 741 over 4, and then times 1/3 or divide by 3 is 247 over 4. And that's your answer. So nothing too complicated in either any of those. It's just the key is to remember, always simplify before you integrate. And just remember the formula for getting average. Remember the formula for getting area under a curve. That okay?
Yep.
So what I'll do is put up, there's a couple, I think there's 2 more questions in that handout. I'll put up 1 or 2 more because the more practice you do, the better. And then if you can practice those for tomorrow, and then I'm going to move on to the next chapter. Okay?
Okay.
And we'll have the test next Monday.
Grand.
Okay, lads. And I'll record over those notes and put that up as well.
Thank you, Biff.
Thanks,
All
mate.
right. Tomorrow.
Thank you.
Right.